Alright, this is a video for Caelen and Sophia for AP Calculus BC, your online course. Let's write down what we know from the problem. We have y equals x squared and y equals d. So our graph essentially looks like this. Since we're going to go down here, y equals x squared, it's a parabola, and y equals d, that's a constant function like that. Every cross-section of the solid is perpendicular to the y-axis, is an isosceles triangle, so that means we have a triangle like that, triangle like that, triangle like that. You have an, go away. Triangle that goes like that. You just have a bunch of these triangles, and that's where the volume comes from. We also have the fact that if I look at any one of those triangles, that this base length here of the triangle, I'm going to call that the base length, and this is going to be the height of the triangle. It has this property where the height is 3 times the base. So the height is 3 times the base. And we also know the volume is 75. So volume is equal to 75. We want to figure out the value of d, and again, d is the height of this line that bounds the parabola. And just as a Desmosy way of showing what's happening, so we have to figure out where this d belongs. Is it up there, down here? Where is that value of d so that we get the correct volume? So how do we do this problem? First, you have to always start by finding the area of this triangle. So I'm again going to draw a triangle here, and so we need to find this length for the base first, and then once we find the base, we'll multiply by 3, get the height, and then we'll find the area. So what is the base? And this base here is in terms of x. We need to get everything, we need to solve for x here, because this length here is x. We're going to solve for x, so I need to take the square root of both sides. X is equal to plus or minus the square root of y. And in fact, you'll see that square root of y, both the positive and negative, is exactly how I got these functions. Positive y was that right half, and then this negative y was the left half. So there's actually 2 halves there to the function. Coming back here to notebook. So this distance here, technically only half the distance right here is, let me come down here so I have a little bit more room. Half this distance is the square root of y. So that means the full length that I was looking for, I have to multiply that by 2, and I get 2 square root of y. Alright, well, that means that our height, we need to multiply that by 3, so this length right here is 3 times that, so it's going to be 6 square root of y. Now we have the base, now we have the height. So again, the formula for a triangle, area of a triangle, it's supposed to be a triangle right there. Triangle is equal to 1/2 base times height, so it's going to be equal to 1/2, and then base is 2 square root of y, so 2 square root of y times height, which is 6 square root of y. Those 2's will cancel out, and I have square root of y times square root of y, which is just y, or square root of y squared, which is just y. So this is going to be 6y. That is the area of this triangle. And now to get this into the realm of volume, that's right over here, into the realm of volume, I need to have some thickness here to make this into a 3D shape. And this thickness I'm going to call d of y. Now I have volume, so let's go ahead and integrate with an infinite number of these dy's. So it's going to be the integral between 0 and, okay, this is going to be all in terms of y, so it starts at a height of 0, ends at a height of d. So from 0 to d of, and my volume is going to be 6y dy. So 6y dy, multiply all of the dimensions together, and I solve. Okay, so when I do this, I'm going to take the antiderivative of y, it goes up a power, divides down, divide by 2, I still have a 6 out there, evaluation bar between 0 and d, and that 2 and 6 are going to cancel out to 3 and 1. And I have 3y squared. When I plug in 0, I'm going to get 0 squared times 3, which is 0, so don't worry about the 0. We're going to be plugging in d, and I get 3d squared should be equal to our volume. And our volume at the very beginning was stated to be 75, so there it is. And then I need to divide both sides by 3, so 75, I can do that in my head, that's 25. d squared is equal to 70, what am I saying, 25, and therefore d, take the square root of both sides, and it's, you normally think plus or minus 5, and you'd be correct in terms of the square root of d, but you have to notice that d has to be a positive value, otherwise you have to find a negative value of d in a whole different way, where this is the shape of your volume, which is very, very different, and that's not what we're doing. So d is equal to 5, that is our final answer, that is d. Question 6, I'm also going to be going over in this video. Consider a solid with base r. Alright, so it's basically the same thing here happening. Slightly different because we know where the area is bounded, it's y equals 8, and we know that it's going to be x cubed, the absolute value of x cubed. So again, as a review, normal x cubed looks like that. That's y equals x cubed. So absolute value of that is going to make this part down here that's negative come back up here to be positive, and it's going to be kind of like a parabola, I guess. So when I do this, again, if I draw my picture, it's basically a parabola, shwink, and again, this isosceles triangle is bounded by this line y equals 8, that's 8 right there, and I have a bunch of these isosceles triangles, a ton of these isosceles triangles, an infinite number of them to make my volume. Let's look and analyze one of those isosceles triangles. Again, I have a base and I have a height, and it tells us that the height is a times as large as the base. So height is equal to a times the base. Okay, so we have our formula set up. We also know that volume is 192. Volume is 192. Are we done analyzing this problem? Anything else we can get out of this? Nope. All right, so from here, we're going to go ahead and reanalyze this triangle in terms of looking at this function. So I need to find the base first. That's going to be in terms of x. I need to solve for x. So when I solve y equals x to the power cube, where that's absolute valued, I have to solve for x by dropping the absolute value, which makes this a plus or minus y is equal to x cubed. That's how I drop absolute value. Then from there, cube root both sides. So the cube root of plus or minus y is equal to x. I have solved for x. By the way, this is the same thing as plus or minus the cube root of y. They're both the same thing. You can have the plus or minus on the inside or outside because you can have the cube root of a negative. You can have the cube root of a positive. It's all in the correct domain. So when I come over here, I say this length right here is the cube root of y. I haven't had the negative part, so this is just the cube root of y right there. That means the full base that I was looking for is twice of that, so 2 times the cube root of y. So now I can find my height. My height, right there, that's equal to a times that. So it's going to be a times 2 cube root of y. All right, now we have our formula ready to go for area of a triangle. Area of a triangle is equal to 1/2 base times height. So the area is going to be 1/2 of the base, which is 2 cube root of y, times height, which is a times the 2 times cube root of y. So those 2's will cancel out, that 2 right there, and I'll be left with cube root of y times cube root of y times a times 2, and that's going to be, that by the way, it's a multiply sign, not a minus sign, so that's going to be, I still have the a out front, and then I still have a 2, so I'm going to make this a 2a, and then cube root of y times cube root of y is just y to the 2/3. I like fractions, they're a little bit easier, and if you don't like that, you can say the cube root of y squared. It's the same thing. So that is the area of the triangle, and again, we need to make it thick to make it into volume. So give it some thickness now, give it a dy, and multiply dy by the area, and you get the volume of that triangle. Coming back here, we can actually do the integral now. The integral between 0 and it told us 8. Just looking at our graph, it went from 0 all the way up to 8, and the volume. So it's going to be 2a y to the 2/3 dy. And I know that I'm going to solve this. I'm eventually going to have an a in it, and I'm going to set equal to 192. Let's go ahead and take the antiderivative here. So antiderivative, it's going to be y to the power of 5/3 divided down, so 3/5. I still have a 2. I still have an a. And that's going to be evaluation bar between 0 and 8. All right, notice when you plug in 0, it's going to be 0 to whatever, which is 0. 0 times whatever is 0. Don't worry about it. That's not going to get anything but 0. 8, however, is going to be plugged in, so it's going to be a times 2 times 3/5 times 8 to the 5/3. Let's go ahead and simplify this expression. By the way, this 8 to the 5/3, let's do an arrow here so we can track what's happening. I have some room up there, so this guy, this 8 to the 5/3 is really 8 to the 1/3 time, or to the power of 5, and as we all know, 8 to the 1/3 is the cube root of 8, which we also know is just 2. So 2 to the power of 5. 2 to the power of 5 is 32. So this whole thing, we can cross it out and say that whole thing is 32. All right, so 32 times 2 times 3 times, or divided by 5. So it's going to be 32 times 2 is 64. 64 times 3, math help me, 64 times 3 is 192. So this is going to be equal to 192 divided by 5, and we still have that a. Again, that is equal to our volume, which is 192. 192, and solve for a. So to solve for a, I need to multiply by 5, divide by 192. So divide by 192, a is equal to 5. Correct answer is A.